Picture yourself in a large space, a warehouse, say, with the lights off. Put whatever you want in that room. People, boxes, whatever. Now, introduce a light source, a focused one, like a laser pointer or a flashlight, and move it around the room. Consider how it interacts with the surfaces it touches. Note that it gets blocked off from some parts of the room by having things in the way, while in other areas it travels further and illuminates the full extent of the space. What you are doing in your mind's eye is illustrating some of the fundamental principles of how we allow users to interact with virtual worlds. This is called Raycasting. This is ASU. When interacting with objects in the virtual world, it's often useful to have functionality where the user can point and click with their mouse, tap on their phone screen, or point a controller to interact with the objects that are in the virtual world. In order to make this happen, we have to use a technique called raycasting. Raycasting does what's in its name. It casts a ray through the virtual world and sees what object it hits. A ray is a straight line that starts from an origin and projects out in a direction. For screen-based devices, the tap on the screen can be projected as a ray that starts from the center of the virtual camera through the pixel on the screen and out into the virtual world. For controllers in virtual reality, the ray can start at the controller and then go in the direction that the controller is pointed. Game engines allow developers to call a raycasting function to see what game objects the ray interacts with. The game objects have collider geometry associated with them. The raycasting then provides to the developer all of the colliders that the ray hits. The developer can then decide what to do with the various objects that the colliders are attached to, or change the state of the entire game, depending on what was clicked. The raycasting function call is configurable to specify certain types of objects, which developers can group as layers. For example, the developer may only want the raycast to select objects that serve as buttons for an immersive user interface. Or they may only want to be able to select ground surfaces. The layers allow for that kind of configuration. The raycasting function also allows developers to specify how far to search along the ray to identify any objects that fall along that ray. Shorter distances will incur less computational overhead, while longer distances will allow for long-distance interactions with things that are farther away. Similarly, developers can tell the raycast to either return all objects that fall along the ray, or just the first object that the ray hits. By only searching for that first object, the game engine has to perform fewer computations in order to return the result. Raycasting is thus a fundamental technique that allows developers to provide object interactions, allowing users to select and interact with different virtual objects through their physical interactions with their screens and controllers. It does, of course, get more complicated than empty warehouses. Imagine how those interactions between rays and surfaces change if your virtual world depicts an urban cityscape. The complexity of the surface that a fixed ray can interact with increases very, very significantly. But the fundamental principles don't change. You might need more computing power, sure, but the application of raycasting still applies in the same way, whatever the nature of the virtual environment you have created. This was ASU. Thanks for watching.